Section 5.8 is on solving equations by factoring. In order to solve these equations, what we're going to do is use what's called the zero product property. Now, this is a property that you already know. We use it all the time, but now we're going to have to use it to solve these equations. So what the zero product property says is that if we have two things we're multiplying, so if A times B is equal to 0, then we know that either A or B has to be 0. So if A times B is equal to 0, then either A or B is equal to 0. So in order to solve equations by factoring, we first have to make sure that the equation is equal to 0. This has to be done before you even start factoring. Then we're going to just use those same factoring techniques we've been using all along in sections 5.4 through 5.7. And then once you've factored, you're going to set each factor equal to 0 and solve. The first example we're going to look at is 3x squared plus 6x is equal to 0. So for this one, and with all our other equations, we're going to start by factoring out a GCF of 3x, and that will leave us with x plus 2, again, all still equal to 0. So now you can see that after doing that factoring, we have two things that we're multiplying together and they equal 0. So this means either the 3x is the 0 or the x plus 2 is the 0. Then we can solve each of these equations. So for this one, we'll divide both sides by 3, and that gives us x is equal to 0. And then here we'll just subtract 2 from both sides, and that gives us x is equal to negative 2. So we have two solutions, x is equal to 0 or x is equal to negative 2. Now we knew we were going to get two solutions because we started with a power of 2. The next equation we're going to factor is a squared minus 81 equals 0. So you can see that this is a difference of squares. So remember, it needs to factor into two binomials that are exactly the same, except one has an addition sign, one has a subtraction sign. So this will factor into a plus 9 times a minus 9, and it's all still equal to 0. So again, here are the two things we're multiplying together, so one of them has to be the 0. Either the a plus 9 is the 0 or the a minus 9 is the 0. If we solve this one, we get a is negative 9, and if we solve this one, we get a is positive 9. So again, because we started with an a squared, we knew we were going to get two solutions. Next, we have a trinomial with a leading coefficient of 1. So in order to factor this, we just need to look for factors of 6 that add to equal 5. So those would be 2 and 3. So this is going to factor into x plus 2 times x plus 3 is equal to 0. And again, we're multiplying two things together that equals 0, so either the x plus 2 is the 0 or the x plus 3 is the 0. And then if we solve each of these, we get x is equal to negative 2 or x is equal to negative 3. Here are our two solutions to our second power equation. For this next equation, what you should first notice is that it does not equal 0. It equals negative 4. So our very first step is to rewrite this and setting one side equal to 0. So that will give us x squared plus 5x plus 4 is equal to 0. Again, this is just a trinomial with a leading coefficient of 1. So we're going to look for factors of 4 that add to equal 5. So those would be 1 and 4. So this will factor into x plus 1 times x plus 4 is equal to 0. Here's our two things being multiplied together. One of those has to be the 0. Either the x plus 1 is the 0 or the x plus 4 is the 0. If we solve the first one, we get x is equal to -1. If we solve the second one, we get x is equal to -4. Again, here are our two solutions to our second power equation. This next equation is also a trinomial, but it has a leading coefficient greater than 1, so here we're going to need to use the AC method. So we start by multiplying 8 and -3, which gives us -24. So we're going to look for factors of -24 that add to equal +10, which tells us our bigger factor is negative. So if you write out a list of factors, you can see this ends up being -2 and +12. If I add those, I get 10. If I multiply them, I get -24. So we're going to just break this middle term apart. So we're going to have 8t squared minus 2t plus 12t minus 3 is equal to 0. And then we're going to go ahead and factor this by grouping. So we're going to group the first two, group the second two. Out of the first group, I can factor out a 2t, so that leaves me with 4t minus 1. Out of the second group, I need to factor out a +3, so remember we put +3. That also leaves me with 4t minus 1. Now that they both have that 4t minus 1, we can go ahead and factor that out. And that leaves us with this 2t and this +3. This is all still equal to 0. So here are our two things being multiplied together that equal 0. Either 4t minus 1 is the 0, or 2t plus 3 is the 0. So if I solve this first one by first moving the 1 over and then dividing by 4, I get t is equal to 1/4. Here I'm going to subtract the 3, then divide by 2. I get t is -3/2. Here are my two solutions to my second power equation. So this next equation looks like maybe we're going to have to use the AC method, but remember your first step is to always check for a GCF. So if you look at all of these terms, we see that we can factor out not only a 2, but a -2 because our leading coefficient is negative. So we're going to start by factoring out a -2. That will leave us with a squared minus 13a plus 36. All still equal to 0. So now you can see we're just left with a trinomial with a leading coefficient of 1, so we don't have to use the AC method at all. We're just going to look for factors of 36 that add to equal -13, so those will be -4 and -9. So this trinomial part is going to factor into a minus 4 times a minus 9. We still have the -2 that we factored out before, and that's equal to 0. So this time we have three things being multiplied together to equal 0, but this -2 can't be the 0. It doesn't have a variable with, it's just a number. So the only things that could be the 0 are the things with the variables. The a minus 4 could be the 0, or the a minus 9 could be the 0. So if we solve both of those, we get a is equal to 4 or a is equal to 9. And again, because we started with a second power equation, we should only have two solutions. Okay, our last example is different because now we have an x cubed. So if we have a third power, we should expect our equation to produce three solutions. The first thing we're going to do, again, is check to make sure it equals 0, and then we're going to start by factoring out a GCF of x. So that will leave us with 6x squared minus x minus 2, again, all still equal to 0. Now we need to check if we can factor this trinomial any further, so we're going to use AC method. 6 times -2 is -12. We're looking for factors of -12 that add to equal -1, so that would be 3 and -4. So this middle term is going to break apart into +3x and -4x, and then we still have that 6x squared and the minus 2. And then we're going to group these, group the first two, group the second two. Out of the first group, I can factor out a 3x. That leaves me with 2x plus 1. Out of the second group, I'm going to be able to factor out a negative 2, so that will also leave me with 2x plus 1. Now that both of these parentheses are the same, I can factor out the 2x plus 1, and that leaves me with this 3x and this minus 2. Again, all still equal to 0, and I have to make sure to include the x that I factored out at the beginning. Now this time we have 3 things being multiplied together, but this one is a variable, and again, we're expecting 3 solutions. So any of these 3 things could be the 0 because we don't know what x is. So the x could be the 0, the 2x plus 1 could be the 0, or the 3x minus 2 could be the 0. This first one's already solved. X could just be 0. If we solve the second one by subtracting 1 and dividing by 2, we get x is equal to negative 1/2. If we solve this one by adding 2 and dividing by 3, we get x is equal to 2/3. So again, we were expecting 3 solutions, and that's exactly what we got.